Hello everyone. We are the students of SRM University, Department of Biomedical Engineering. This is the overview of a final year project on the topic Detection of Exudates in Fundus images using image processing. The work is done by Devika Vinay, Ashwani Ajayakumar, Merlin Matthew under the guidance of Ms. P. Vinupreeta, Assistant Professor, Department of Biomedical Engineering, SRM University. The aim of the project is to detect exudates in fundus images using image processing. An introduction to this concept should start with the very term diabetes. As 80% of population strives with various stages of diabetes, it has become a global challenge. If not diagnosed and treated in time, diabetes can lead to series of illness in the human body. It can also affect the retina and retinal structure of human eye in certain ways. This screening for detection of such abnormality in the retina is called diabetes retinopathy. The latest technological advance in image processing helps auto-detection of diabetic retinopathy based on the analysis of feature extraction. This analysis not only helps diagnose the disease but also helps detecting the severity of the disease. There are n number of existing methods like ridge-based fundus segmentation, computer-driven tracing of fundus network, adaptive local thresholding. There are disadvantages associated with these prevailing techniques like non-uniform illumination, presence of other anatomical structures, variable fundus characteristics that do not generalize. The objective of the proposed idea is to collect input images, to perform processing techniques on the image to improve the visual appearance of the image, segment the image and detect presence of affected part like exudates, to classify whether affected or not, to find accuracy of neural network system used to compare normal and abnormal retinal image. The block diagram represents the series of workflow which can be explained with a methodology. Collect input data images, that is the fundus images, extract the green plane, perform histogram equalization, apply erosion and dilation method for optic disc removal, contrast enhancement, segmentation using thresholding, apply Haar wavelet transform, image classification using neural networks. These steps are clearly explained in series in the block diagram. Now the pre-processing steps include the elimination of errors caused during taking the image and to reduce brightness effects on the image. Images in green bands show fundus structures most reliably. So the green band was extracted. Now the input image or the test image is taken. Green channel is extracted out. Now histogram equalization is performed. Then erosion dilation which is the part of optic disc removal is done. Later we're finding the threshold of the image. It's part of segmentation. Then we're applying Haar wavelet transformation. In the transformation, we can get 4 planes: approximation coefficient, horizontal detail, vertical detail, diagonal detail. Later, the exudates are detected, and these detected exudates or reconstructed image is traced back to the original image for easy diagnosis. Thus, the exudates can be mapped on the original image. That's the output image. This is the final steps which is involved in the processing, but later the classification steps are there. A neural network based performance analysis is obtained, where we can find the training confusion matrix, validation confusion matrix, test confusion matrix, and all confusion matrix. These all give the percentage. In the post-processing steps, the exudates are extracted in this step and traced back to the input image to detect the exact location of exudates in retinal image. Let's summarize this way. The need and use is to extract exudates. Research is ongoing, and there is still a great need to develop for easier and more accurate and useful algorithms. We were able to detect the exudates. Better algorithms can be developed using MATLAB tools for extraction of microaneurysm and hemorrhages. Now let's talk about the software requirements. As this has the complete assistance of a software, we use MATLAB 2015 here for the image processing. MATLAB is a scientific programming language and provides strong mathematical and numerical support for implementation of advanced algorithms. It is for this reason that MATLAB is widely used for image processing and computer mission community. New algorithms are very likely to be implemented first in MATLAB. Indeed, they may only be available in MATLAB. This is the reference. Thank you for watching.